Hello. For the conclusions, like this one says it was failed to reject. And we were testing. There's the null right here. Greater than. So we failed to reject. The final conclusion, when you're concluding, if you fail to reject, then it's not significantly more. So this one makes sense. But this one says not significantly more also. Now the difference between the two, this one is stating the null hypothesis, where this one is stating the alternative. You don't want to talk about the null hypothesis, the one that was equal to, and that's why it's this one. So it's not significant because we failed to reject, and there's insufficient evidence that the mean number of customers is more than 193. So you are saying it's not significant, and you're talking about the alternative hypothesis and not the null one. And that's why it's this one. When we interpret the p-value, the p-value was 0.14. And so the population number of customers since the ad campaign began collecting is 14 days. And that would be the p-value is your chance of it happening. 14% chance that it would be greater. So your p-value gives you the percent of chance that it's greater, because greater is what we were testing. The level of significance was, I think, 10%. Our alpha, 0.10 multiplied by 100 is 10%. And if the population mean number of customers since the ad became is 193, and if you collect the data for another 14 days, then there would be a 10% chance that we would end up falsely concluding that the population mean customers since the ad began is more. The alpha or significance level tells you the percent that you would be wrong. I guess that's how you can count it. %10 of the time we would state that it was greater even though it's not. The other one that you had a question on, I guess it's the same things. On this one we were rejecting, and we were testing not equal to. So since we're rejecting, it's significant. The data is significantly different from 5.2. So it would be this one. These two would only be the case if it was do not reject. Interpreting the p-value tells you the percentage. What was our p-value? Multiplying that by 100, it's 0.88%. The population mean number of accidents per year at an intersection with cameras installed is 5.2. And if another 69 intersections, there would be a 0.88% chance that the sample mean for these would either be less than or greater than, and that's because we tested not equal to. So this tells you, the p-value tells you the chance the sample mean will be, depending on what you're testing, greater than, less than. Where this one's what? The level of significance which was 0.01 multiplied by 100, 1%. That tells you your error. Population mean number of accidents per year in an intersection with cameras is 5.2. And if another 69 intersections with cameras installed is observed, there would be a 1% chance that we would falsely conclude the alternative hypothesis. So it's a 1% chance that you pick the alternative.